This is the final problem in this section for the normal tangential components of acceleration in the curvilinear sections of the book. Remember, this chapter is very long, and it introduces you to the foundation of everything you're going to be doing for the rest of the semester. Here, this problem seems a little, I guess, like too easy for being the last problem of the fundamental problems. But let's just dig in. So, givens are, we have our what's it called? Our radius. Okay. Whatever. Drawing a blank here. So we have the radius here of 500 meters. We're trying to determine the magnitude of its acceleration when it is at point S equals 50. So what is A at S equals 50 meters? Okay, and then they give us the velocity of point 2 S. Okay, so again, giving us a velocity with respect to some distance. Okay, well, first let's calculate my velocity at point S equals 50. So it's 0.2 times S equals 50. All right, and let's see, that'll be 2 tens, that'll be 10 meters per second. All right, and we know why am I calculating the velocity? Because we're going to need it for the normal component of acceleration, right? So now my normal component of acceleration at S equals 50 is going to be 10 squared divided by rho, radius of curvature. Right, so it's 100, or so that's going to be 0.2 meters per second squared. Okay, so that was pretty easy, right? The last thing we need to do is, we need to find the tangential component of acceleration. So, which is dv dt, right? Which I guess we can also write down as, again, chain rule, ds dt, which this is v, right? ds dt is just velocity, and then dv ds. But for v, I'm just going to plug in what v is, which is 0.2 s. Okay, and then here we'll draw. Let's write down what v is first. So 0.2 s, right? And now what this second term is, which is the first derivative of 0.2 s, which is going to be 0.2. All right, and then this will give us 0.04 s. All right, like I said, surprisingly easy for it to be the last problem of this section. All right, so then AT at S equals 50, yes, S equals 50. All right, that'll give us 2 meters per second squared. All right, and then finally we just take our magnitude. So it's going to be 2 squared plus 0.2 squared, and then we end up getting 0.201 meters per second. Okay, and then let's see. So if you were to draw out this vector, right, the tangential component, let's say this is 1. All right, this is 2 units. Okay, 2 meters per second squared. So let's see, this is 1, so 0.1 will maybe be like here. Okay, so this is the normal component of acceleration is 0.2, right? So then our final vector, like if you were to try to imagine what this looks like, it's going to be an plus at right? So it's going to be AN plus AT, right? So it's going to be something like this, and that is A. All right. So if you get into the angles and everything like that, just try to visualize it first. That way you can begin to see, okay, what's that angle, what's this angle, and so on. All right, guys. Yeah, hope this video helped. I hope this these last like 6 problems really, you know, gave you a good foundation of how to go about these problems. And yeah, thanks a lot for your time, guys. If you have comments, questions, concerns, just drop them down below, and don't forget to subscribe and like the video. Thanks.